The basement laboratory in Berlin held secrets that would change everything. Dr. Heinrich Volkmann gripped the decoded transmission with trembling fingers. His worst fears were becoming reality. September 12, 1944. Morning light filtered through the Kaiser Wilhelm Institute windows. The intercepted American intelligence lay scattered across Volkmann's desk. Each page revealed truths that shattered German confidence. America had done the impossible. While German scientists debated theory, their enemies had built actual weapons. The documents proved it beyond doubt. 3 times Volkmann read the transmission. Each reading made the situation clearer. The United States wasn't just researching atomic weapons. They were months from using them. The revelation hit like a physical blow. German nuclear physics had led the world for decades. Otto Hahn and Fritz Strassmann had split uranium atoms in 1938, right here in Berlin. 6 years before this moment of truth. Everything they believed was wrong. The intercepted reports came through Operation Bernhard's communication network. Allied messages revealed a shocking reality. American capabilities exceeded every German estimate. Professor Werner Heisenberg had assured Nazi leadership that atomic bombs remained impossible. His calculations from 6 months earlier painted a different picture. Any functional weapon would require uranium facilities the size of entire cities. Such projects were economically impossible during wartime. The Americans had proved him wrong. Oak Ridge, Tennessee, employed over 75,000 workers. The secret installation dwarfed most German industrial centers. Hanford, Washington covered 586 square miles. Plutonium production reactors operated at scales German scientists had only imagined. Dr. Klaus Clusius analyzed the technical specifications. Volkmann's deputy had studied under Max Planck himself. The American solutions to uranium separation problems were brilliant. Their gaseous diffusion plants processed material at impossible scales. German experimental efforts looked primitive by comparison. The psychological impact devastated the German team. These men considered themselves Einstein's intellectual heirs. They had given birth to quantum mechanics and modern physics. American industrial capacity had transformed their theoretical knowledge into practical weapons. One detail crystallized the magnitude of German miscalculation. Americans pursued multiple atomic weapon pathways simultaneously. While German scientists debated approaches, America developed uranium enrichment and plutonium production. Massive resource commitments dwarfed Germany's entire war economy. German atomic research had begun with every advantage. Hahn and Strassmann achieved nuclear fission in December 1938. Berlin laboratories had produced more Nobel Prize winners than anywhere else on Earth. Professor Abraham Esau commanded unlimited resources after his 1939 appointment as Reich Research Leader for Nuclear Physics. The Reich Research Council allocated substantial funding. Uranium supplies from occupied Czechoslovakia seemed endless. Germany's brightest scientific minds received orders to unlock atomic energy's military potential. By 1940, the Heereswaffenamt classified all nuclear research as kriegsentscheidend, militarily decisive. Yet fundamental miscalculations doomed German atomic research from inception. Bureaucratic competition between rival Nazi organizations created the first critical error. The Reich Research Council competed with the SS Ahnenerbe. The Luftwaffe Technical Office established separate programs. The Navy's research division duplicated efforts. Dr. Kurt Diebner represented the SS as an Oberführer and physicist. His team competed directly with Heisenberg's Kaiser Wilhelm Institute group. Rivalry prevented crucial information sharing. Already limited uranium supplies split between competing research tracks. American scientists at Los Alamos collaborated under unified military direction. German researchers hoarded discoveries to protect bureaucratic territory. Resource allocation created the second devastating miscalculation. German leadership expected quick victory through conventional means. They refused commitment to long-term research projects. Reich Minister Fritz Todt delivered crushing news in 1940. Any weapons development requiring more than 2 years would receive minimal support. This decision eliminated Germany's atomic weapon chances during the war. Professor Paul Hartek proposed gaseous diffusion techniques at Hamburg University in 1940. The same methods Americans would use successfully at Oak Ridge. His proposals faced rejection as too resource-intensive and theoretically uncertain. The Reich Ministry of Education allocated funding equivalent to Los Alamos cafeteria operations for 1 month. Allied bombing campaigns created additional challenges American counterparts never faced. The Kaiser Wilhelm Institute suffered 3 direct hits in 1943. 2 years of experimental data vanished. Research teams scattered across rural locations. Equipment shortages became chronic as war production prioritized conventional weapons over speculative research. Most critically, Germany had expelled or murdered many brilliant physicists. Einstein, Szilard, Fermi, and dozens of other scientific refugees now worked for America's Manhattan Project. The brain drain beginning in 1933 had transferred Germany's atomic advantage directly to enemies. German leadership remained oblivious to this transfer's significance. German atomic research stagnated around theoretical reactor designs by 1942. These showed promise for power generation, but offered no clear weapons pathway. Heisenberg's team achieved nuclear chain reactions in small experimental piles. Scaling experiments to weapons-grade material production required industrial commitments exceeding Germany's available resources. The intelligence reports revealed how American industrial capacity overwhelmed German scientific advantages. German researchers operated with handfuls of graduate students and improvised equipment. Los Alamos employed thousands of physicists, chemists, and engineers. Purpose-built facilities operated with unlimited budgets. Dr. Walter Gerlach had replaced Esau as Atomic Program Director in 1944. His recent reports estimated Germany might achieve a functional atomic reactor by 1947. This assumed continued resource allocation and no further bombing disruptions. Intercepted American documents revealed the United States had already constructed multiple production reactors. Weapons-grade plutonium manufacturing operated at industrial scales. The breakthrough dooming German atomic ambitions began 3 years earlier. Dr. Enrico Fermi achieved the world's first controlled nuclear chain reaction at Columbia University on December 2, 1942. The Italian physicist had fled Mussolini's racial laws. German scientists didn't realize this moment marked America's transition from theoretical research to industrial-scale weapons production. General Leslie Groves received appointment to lead the Manhattan Project in September 1942. Within 18 months, he had transformed atomic research from academic pursuit into the largest scientific industrial undertaking in human history. The United States constructed 3 massive secret facilities dwarfing Germany's entire scientific infrastructure. Oak Ridge engineering achievements astounded German researchers. American engineers solved uranium enrichment through multiple parallel approaches. The K-25 gaseous diffusion plant covered 44 acres under a single roof. It consumed more electricity than many American cities. The Calatrons at Y-12 used electromagnetic separation techniques German scientists had dismissed as impractical. The scale shocked German researchers most. Oak Ridge employed more physicists than existed in all occupied Europe. Dr. Robert Oppenheimer's leadership at Los Alamos represented everything German atomic research lacked. While German scientists competed in bureaucratic rivalries, Oppenheimer unified America's brightest minds under military discipline and unlimited resources. The scientific city description stunned German analysts. Theoretical physicists worked alongside explosive experts. Metallurgists collaborated with electronics specialists. Pure research transformed into engineering solutions within weeks. American plutonium production revealed industrial thinking German scientists had never imagined. DuPont Corporation constructed production reactors at Hanford using chemical manufacturing techniques. German researchers debated reactor theory, while Americans built machines producing weapons-grade plutonium by the kilogram. Professor Niels Bohr's defection to America in 1943 provided crucial theoretical insights, accelerating weapons design. Bohr had mentored an entire generation of European physicists. Now he advised American bomb designers on critical mass calculations and assembly mechanisms, remaining mysteries to German researchers. American innovations challenged fundamental German assumptions about atomic weapons. Critical mass requirements previously estimated by German scientists at several tons of uranium had been reduced to manageable quantities. Sophisticated implosion techniques solved the problem. Americans had resolved weapons assembly using conventional explosive expertise that Germany's fragmented research programs couldn't access. Most devastating was discovering America pursued multiple bomb designs simultaneously. German scientists debated whether uranium or plutonium offered better prospects. Americans had developed both pathways to operational weapons. Little Boy uranium design and Fat Man plutonium implosion bomb represented parallel innovations guaranteeing American success regardless of technical challenges. Intelligence communications revealed testing schedules confirming German fears. Trinity, the code name for America's first atomic test, was planned for July 1945 in the New Mexican desert. After 3 years of theoretical discussions, German scientists realized their enemies would demonstrate functional atomic weapons within months. Dr. Volkmann understood German atomic research had fundamentally misunderstood the challenge. German scientists approached atomic weapons as theoretical physics problems, requiring elegant solutions. Americans treated bomb development as an engineering challenge requiring industrial solutions. This philosophical difference determined the outcome before German researchers recognized competition had begun. July 16, 1945, Aero 529 hours. Trinity test in the Alamogordo Desert confirmed every German scientist's worst fears. Intercepted American communications decoded by German intelligence 3 days later described devastation beyond imagination. The fireball rose 38,000 feet into New Mexican sky. A crater 1,200 feet wide marked ground zero. The theoretical had become devastatingly real. Dr. Volkmann received the Trinity report while German atomic researchers gathered for their final wartime conference at Stadtholm. The timing proved cruelly ironic. German physicists debated whether atomic weapons remained theoretically possible, while American scientists had just proven their practicality. A blast equivalent to 21,000 tons of TNT left no room for doubt. German intelligence networks had intercepted Allied communications efficiently. Yet they failed to grasp the Manhattan Project's true scope until operational testing revealed American capabilities. Colonel Erwin Respondek served as Germany's chief scientific intelligence officer. He had dismissed earlier reports about Oak Ridge and Hanford as Allied disinformation designed to waste German resources on impossible projects. Professor Max von Laue analyzed Trinity test data with growing horror. The Nobel laureate served as Volkmann's senior advisor. Americans had achieved nuclear fission efficiency that German calculations deemed impossible. Critical mass requirements, German theory predicted, would require tons of uranium, had been reduced to manageable quantities through implosion techniques German researchers had never considered. Operational details shattered German assumptions about atomic weapons deployment. The Fat Man plutonium bomb weighed 2,800 pounds and measured 10 feet 8 inches in length. These dimensions made aerial delivery feasible using existing bomber aircraft. German scientists had calculated that any functional atomic weapon would require specialized delivery systems that wouldn't exist for decades. Dr. Carl Friedrich von Weizsäcker attempted to reverse engineer American success from intercepted technical specifications. Heisenberg's protege and theoretical specialist made disturbing calculations. The gaseous diffusion plants at Oak Ridge had processed uranium volumes exceeding Germany's total wartime uranium stockpile by factors of hundreds. American bomb assembly mechanisms demonstrated engineering sophistication German research had never approached. Implosion lenses used in the plutonium device required precision explosive manufacturing, integrating conventional weapons expertise with nuclear physics. German atomic research isolated within academic institutions lacked access to explosive specialists who might have solved these practical challenges. August 6, 1945, Hiroshima. The Enola Gay dropped Little Boy at 08:15 hours local time. 5 square miles of the Japanese city vanished instantly. Approximately 80,000 people died in the first moments. German monitoring stations detected the blast's seismic signature within hours. American atomic weapons had transitioned from successful tests to operational deployment. The Hiroshima bombing revealed American strategic thinking German planners had completely misunderstood. German military doctrine emphasized precision targeting of specific installations. Americans had designed atomic weapons for area destruction, eliminating entire cities. The psychological impact on civilian populations represented warfare concepts traditional German military thinking hadn't anticipated. August 9, 1945, Nagasaki. Fat Man detonated at 1102 hours local time. America possessed multiple atomic weapons and could conduct sustained atomic warfare. The 3-day interval between bombings demonstrated production capabilities, making American atomic superiority permanent and overwhelming. Intercepted communications from Japanese sources described destruction beyond conventional comprehension. Temperatures at ground zero reached 7,000 degrees Fahrenheit. Human beings vaporized instantly. Steel structures melted like wax. Radioactive fallout created contamination zones, remaining lethal for weeks after initial explosion. For German scientists, Nagasaki represented final confirmation of their complete failure. They had spent 3 years debating theoretical possibilities, while America developed, tested, and deployed multiple atomic weapons in combat operations ending the Pacific War within days of first use. Psychological devastation among German scientists proved as complete as physical destruction in Japan. Dr. Volkmann's team had considered themselves inheritors of Einstein and Planck's legacy. Now they faced reality that German atomic research had become irrelevant months before Germany's surrender. Intercepted American communications revealed the crucial difference. German physicists had remained theoretical while Americans became decisively practical. Professor Heisenberg's reputation, built on decades of groundbreaking theoretical work, crumbled under his miscalculations' weight. His assurances to Nazi leadership that atomic weapons remained impossible had been proven catastrophically wrong within months of Germany's defeat. Post-war interrogations by Allied intelligence officers revealed Heisenberg had fundamentally misunderstood engineering challenges involved in weapons development. The farm hall transcripts recorded secretly by British intelligence after Germany's surrender captured German scientists' real-time reactions to Hiroshima. When BBC broadcasts announced the atomic bombing, 10 German physicists held at the English countryside estate initially dismissed reports as Allied propaganda. Their disbelief transformed into shocked recognition as additional details confirmed American atomic success. Dr. Otto Hahn suffered a complete nervous breakdown upon learning his scientific breakthrough had enabled mass destruction. The man whose 1938 research had unlocked atomic energy felt personal responsibility for weapons killing hundreds of thousands of Japanese civilians. His farm hall colleagues feared for his mental stability during days following Hiroshima. German scientific community post-war analysis revealed systematic failures extending beyond individual miscalculations. The Reich's bureaucratic competition had prevented crucial collaboration. Resource limitations made large-scale experimentation impossible. Most critically, expelling Jewish physicists had transferred Germany's atomic advantage directly to American laboratories. International scientific opinion shifted dramatically against German researchers who had served the Nazi regime. The Allied scientific community had previously respected German theoretical contributions. Now they viewed German atomic research as both incompetent and morally compromised. German physicists found themselves excluded from post-war international conferences and collaborative research projects. Strategic implications of German atomic failure became apparent as the Cold War emerged. The United States possessed atomic monopoly that would dominate international relations for decades. German scientists realized their theoretical discussions had occurred while America built weapons reshaping global power structures permanently. Soviet atomic research accelerated by captured German scientists and American secrets obtained through espionage achieved successful weapons tests by 1949. The atomic age German research had initiated would be dominated by superpowers who learned from German mistakes while avoiding German limitations. Dr. Volkmann's personal correspondence, released decades later, revealed profound regret experienced by German atomic researchers. They had possessed theoretical knowledge that could have changed history. Bureaucratic failures and resource limitations had prevented practical application. Knowledge that atomic weapons were possible had been insufficient without industrial commitment to make them real. German atomic program failure influenced post-war scientific policy in ways German researchers never anticipated. American success demonstrated that large-scale government investment in scientific research could achieve seemingly impossible goals. This lesson would drive space programs, computer development, and medical research for generations. Contemporary analysis of German atomic research reveals that theoretical brilliance without practical implementation remains academically interesting but strategically worthless. German scientists who unlocked atomic secrets discovered that knowledge without application equals irrelevance in warfare's ultimate test. The atomic bombs ending World War II had been built using German scientific discoveries by German refugee scientists working with American industrial capacity. This ironic reality haunted surviving German physicists for the remainder of their careers. They had initiated research that enemies completed more successfully. Final irony of German atomic research emerged in decades following World War II. Scientists dismissed as theoretically brilliant but practically useless became foundational figures in peaceful atomic energy development. Dr. Volkmann, Dr. Heisenberg, and colleagues channeled expertise into reactor design and nuclear power generation. They finally achieved practical applications of atomic research under international supervision. The farm hall transcripts, declassified in 1992, revealed conversations fundamentally changing historical understanding of German atomic capabilities. These secretly recorded discussions proved German scientists had genuinely believed atomic weapons impossible during wartime. They weren't deliberately sabotaging Nazi war efforts, as some post-war accounts suggested. Their failure had been intellectual, not moral resistance. Modern analysis of the German atomic program reveals lessons extending far beyond World War II history. The Reich's fundamental mistake, treating atomic research as competitive academic exercise rather than collaborative industrial project mirrors, failures in contemporary technology development. Theoretical knowledge without practical implementation remains academically interesting but strategically irrelevant. Brain drain that crippled German atomic research established patterns continuing to influence international scientific competition. Nations suppressing intellectual freedom lose innovative capacity to countries welcoming diverse perspectives. Jewish physicists expelled from Germany between 1933 and 1939 didn't simply leave. They transferred German atomic advantages directly to American laboratories. Dr. Volkmann's memoirs, published in 1963, acknowledged German atomic research had been doomed by philosophical misunderstanding of modern warfare's industrial nature. German scientists approached atomic weapons as theoretical physics problems requiring elegant solutions. Americans treated bomb development as engineering challenges requiring practical solutions backed by unlimited resources. Manhattan Project success established the template for big science dominating the remainder of the 20th century. Large-scale government investment in scientific research, coordinated through military-industrial partnerships, achieved seemingly impossible goals. From atomic weapons to space exploration to computer development, this model proved decisive. German atomic research had remained small-scale and academically focused, while history moved toward industrial scientific solutions. Contemporary nuclear proliferation reflects lessons learned from German atomic failure. Nations seeking nuclear weapons now understand theoretical knowledge alone provides insufficient foundation for weapons development. Successful nuclear programs require sustained industrial commitment, international scientific collaboration, and decades of systematic development. Exactly what Germany had lacked between 1939 and 1945. Psychological burden carried by surviving German atomic scientists influenced their post-war advocacy for nuclear arms control. Having witnessed American atomic success achieved through German scientific discoveries, they became powerful voices warning against nuclear weapons proliferation. Their unique perspective as scientists who initiated atomic research but failed to complete it provided moral authority for peace movements. Educational institutions worldwide now study the German atomic program as a case study in scientific management and international competition. Business schools analyze bureaucratic failures that prevented German coordination. Policy schools examine how brain drain undermined German scientific advantages. The lessons extend far beyond nuclear physics into contemporary technology competition. The 8 intercepted American communications revealing German atomic failure to Dr. Volkmann in September 1944 had predicted not just American atomic success. They foretold broader transformation of scientific research from individual brilliance to collaborative industrial effort. German scientists discovered too late that in modern technological warfare, organizational capacity matters more than individual genius. Today, the former Kaiser Wilhelm Institute operates as the Max Planck Institute. It conducts peaceful scientific research under international cooperation principles German atomic research had lacked. The building where Dr. Volkmann first learned of American atomic success now houses laboratories where German and international scientists collaborate on projects benefiting humanity rather than destroying it. The morning Dr. Volkmann held those trembling intelligence reports marked more than German atomic failure. It represented the moment theoretical physics yielded to industrial engineering as the decisive factor in modern warfare. The age of individual scientific genius had ended. The era of collaborative technological development had begun.